Hello everyone, welcome to our channel. This is our DSAA6000L term project. We are Group 2. This project is about fraud detection, fighting financial crime with machine learning. Let's see a TV show called The Office, where these two people, Pam and Jim, were on their honeymoon, and their colleague was in Jim's office.
Hello?
Hello, Mr. Halpert. I'm calling from the Identity Theft Department at Capital One. We've detected some unusual activity on your credit card.
Oh man, do you think it was stolen?
Sir, did you mind verifying your home address?
Yes. 383 Linden Ave, Scranton, PA.
And may I have the last four digits of your Social Security?
6650.
Well, Mr. Halpert, you're obviously not in San Juan, Puerto Rico.
Wait a minute. Yes, I
I'm going
am.
to go ahead and put a hold on your card.
No. I think that we should let the criminal use the card a little longer.
Very funny, sir. We'll get a new card out to you right away.
No.
Have a nice day, and thank you.
So unfortunately, Jim's credit card was blocked. This episode actually shot on 2009, and which is more than 10 years ago. There was an important travel rule that you have to notice the bank when you are abroad so that your credit card won't get blocked. But from 2015, bank has announced that people don't have to notify when they are on a travel. They will send a code to a customer to confirm payment when they detect unusual activity. Also, techniques are developing in credit card fraud detection these days. Here comes machine learning. So what is machine learning? We know that humans always learn from X experiences, and computer tends to follow instructions. We want computers could also learn from experiences, and actually they can do it. But they can do this by learning from historical data. So why machine learning? Machine learning can spot sneaky patterns humans might miss and adapt to new fraud tricks fast and reduce annoying false alarms for legit customers. And also can mark in real time to stop fraud before it happens. We know fraud detection now faces two key challenges. The profiles of normal and fraudulent behaviors change constantly, and credit card fraud datasets are highly skewed. Today, this project is going to use Six Sigma methodology, which means define, measure, analyze, improve, and control. Here comes the define phase. Credit card fraud detection needs to address severe class imbalance, dynamic fraud patterns, and real-time constraints. So the objective of this project is to develop an efficient, accurate, and easy to maintain fraud detection method.
Here comes the measure phase. We have a fraud detection dataset from Cargo. The fraud rate is 0.32%, and it's a dataset with date, amount, location, time, and is fraud or not. The amount in the three data is pretty high, and the dataset tagged it as a true fraud. Then we come to the analyze phase. Data exploration is like detective work. Before solving the case, you need to know the clues. Stakeholders often care not just about the end results, but about gaining an understanding of the data. And here's why. Insights from these explorations can shape the way we train models and improve decision making later on. First, we take a look at these two histograms. On the left, we see the distribution of fraud transactions, and on the right, non-fraud transactions. What do you notice? Fraud transactions are generally concentrated in smaller accounts, most under $400, This may be because fraudsters aim to evade detection by keeping transactions low. On the other hand, non-fraud transactions are more varied and include a significant number of larger amounts. To verify these observations, we turn to hypothesis testing. Let's test if fraud and non-fraud transactions have significant different average amount. The null hypothesis is fraud and non-fraud transactions have the same average amount, while the alternative hypothesis is fraud and non-fraud transactions have different average amount. Display of the statistical result. We can see that the result is clear and the p-value is really slow, so we can get that fraud transactions have significantly higher average amounts than non-fraud ones. Now let's move to merchant categories. Are fraud transactions in certain categories more significant than others? To answer this, we use ANOVA. The null hypothesis is the average fraud transaction amount is the same across all merchant categories, while the alternate hypothesis is at least one merchant category has a significantly different. We can see the result. With a p-value that is really small, we reject the null hypothesis, and the fraud transaction amounts significantly vary across merchant categories. But which categories are driving these differences? Specifically, we use the Turkey HSD test to identify significant pairwise difference between merchant categories. This is some of the results we get, and we can see that fraud transactions in online gifts and online retail are significantly high. From those roughly insights of the dataset, it can be discovered that transaction behavior and merchant categories are significant features in the dataset. Based on this discovery, let's see a specially designed machine learning algorithm to solve the problems we defined before.
To use the information from these two features, there is a novel network-based credit card fraud detection method based on representation learning. Now let's introduce some brief introduction about the model structure. In the training stage, the first step is to transform input translate data into a three-part transition network. To see this picture, assume that you are at a store, happily purchasing something with your card. You complete the purchasing and walk out. But this interaction is more than just a straightforward exchange between you and the merchant. It actually has a complex network, links to your bank, the payment processor, and even the shipping company if it was ordered online. In this network, each credit card transaction can be viewed as a three-part relationship involving three main rules. The first one is cardholder. That's you who behave the transaction. And the second one is merchant, the store or service provider that accepts your payment. The third one is transaction, the specific purchase that connects the cardholder and the merchant. In this network, a connection is established between these three parts. Each component plays an important role within the network. Through this, we got a clear understanding of the dynamic of transaction and the interrelationship between the various roles involved. And based on the network we have built, it introduced a special rule, the from node. Whenever we identify a transaction as from or a normal, it gets connected to this special node. This way, all transactions labeled as from and are linked to this artificial from node. Now assume if there are multiple transactions identified as from, they would form a tight connected little group through this from node. This connection makes it clear how different they are from normal transactions. You can think of this little group like a secret society, where only the problematic transactions are allowed in. By doing this, it can better divide from transactions. Now, let's divide into an interesting part, representation learning. It might sound complicated, but it's actually pretty straightforward. We are going to transform cardholder nodes, merchant nodes, and transaction nodes into a lower dimension feature space. Imagine you are in a party and everyone is chatting. In this feature space,
The distance and position of each person reflect their relationship with one another. By mapping these nodes into low-dimensional vector space, we can see how they relate to each other, showing certain patterns of correlation from the original transition network. This way, we can easily divide which transitions are normal and which one may be problematic. In the final step, it introduced a very powerful tool, SGBoost, to help us determine whether a transition may be found. You can think of SGBoost as a clever detective. They relies on analyzing a vast amount of historical data to uncover potential from patterns. The core principle of SGBoost is boost trees. It creates many decision trees, with each tree improving upon the former one, gradually increasing the performance of its judgments. It's like a detective collecting new rules during the investigation to refine their reasoning. Whenever it identifies a transition that shares similarity with past fraud case, it raises an alert. We will input the mentioned embedding as feature into the SGBoost model. This embedding acts like an idea for each transition, containing rich information that helps the model better understand the content of each transition. SGBoost carefully analyzes these features, searching for patterns that are highly correlated with fraud transition, and continuously learns to enhance its judgment capabilities. Now we compare the performance of this model with classic machine learning methods, include logic regression, decision tree, and also random forest. The results are at the bottom of the video. There are also two kinds of learning methods, SGBoost and K-means. The results also at the bottom of the video.
Okay, so now let's see the experiment result of this project. And the average precision was 0.24 and F1 score was 0.2876, which both higher than the classic machine learning model we have mentioned before. And from the picture, we can see that the relationship between the precision and the recall.
Now that we have explored the fascinating world of fraud detection, let's look at how banks actually use machine learning to safeguard transactions in real time. When you swipe your card at the store or make an online purchase, your transaction data doesn't just disappear. Instead, it flows through a monitoring system powered by machine learning models. This model analyzes your transaction against previous records, looking for patterns. Is the purchase unusual? Is the location suspicious? Or did the card get used a moment ago halfway across the globe? When something seems abnormal, the system acts fast, sometimes even faster than a human fraud analysis could. It might notify you immediately with a text or email, or in some cases, temporarily freeze your card until the issue is resolved. This approach means fraudsters have less time to cause damage, and you, as a customer, can feel secure knowing your bank has your back 24/7.
Fraud detection isn't just about stopping bad guys, it's about protecting your hard-earned money and make sure your transactions are safe and seamless. With the power of machine learning, banks are staying one step ahead, ensuring smarter, faster, and safer financial systems for everyone. Thanks for joining us today. If you found this video insightful, don't forget to like and share. Have any questions about fraud detection or machine learning? Drop them in the comments. We'd love to hear from you. Thank you.